Welcome to the first Society of Amateur Radio Astronomer Drake's Lounge, Australia. Society of Amateur Radio Astronomers was started in about 1983, and they've put over 200 journals together. We've got a SARA YouTube channel. If anybody hasn't seen the YouTube channel, that's a good place to start, especially if you're starting out. We've got a fully indexed on our webpage. We got a fully indexed article count for all the journals, so you can just look up any topic and go to the journal in question. We'll see. SARA membership is only $20 a year, and that's so everybody gets all the news articles and stuff like that. Let's see what else. We do have a SARA. I was telling Roger, we do sell about 3 different radio telescopes on our website, and one is the Super SID, which is out of Stanford, which does solar flares. It's a 27 kilohertz solar flare detector. I've had mine for 5 years. And it's fully automated, and it actually reports back to the Stanford website. I've even detected the 2017 eclipse with it. So it's very good. The Radio Jupiter, we are fully hooked up with the Radio Jupiter Pro guys, and they, in fact, if you look on the website, I just hooked it, put all their videos on our website, or on our YouTube channel. And they just came out with the Radio Jupiter 2, which is the actually an SDR play as opposed to the manual one they did. And that is so you can pick up the 20 megahertz Jupiter interaction with between Jupiter and its first moon Io. And you can pick up the different L and S bursts, and even some N bursts. We just came out with what we call a scope in the box. And the scope in the box is a hydrogen receiver with a small antenna. So basically you can pick up the galaxy coming over, but that's a very good start. And once you got that working, then you can enhance that. We've got lots of videos on how to enhance that small antenna, which is just a really small microwave dish. And but you can hook the same thing up to a larger dish and get it better. So that gets you up to hydrogen. We've got multiple groups that are doing pulsars, and a lot of pulsar development and explanations how to run the software. And then we've got a number of people that are doing masers. So masers, another astronomical capability there. I think Roger was talking about potentially getting an interferometer working. I think that we've got a couple of people that are doing interferometers. I'd recommend looking at Wolfgang Herrmann's YouTube video keynote about how he's got an interferometer set up on his site and how that's set up. But interferometry is really fun. I personally and a couple other people are using the 20-meter dish at Green Bank, which is a remote operated one. Which, if you're a member of our society, we've got a lot of hours that we can lend you guys to get use the 20-meter dish, and that thing picks up pulsars, hydrogen, masers, everything. It does everything, and it automatically processes it. So to get started, if you want to use the 20-meter dish, that's really good. And it's fully remote operated, so you guys can do it from where you're at. Let's see what else. The other thing is we do have our meetings at usually the VLA in New Mexico and the Green Bank with the big dish out there. And we are fully hooked up with being able to take the archive data from those dishes in those large interferometers and processing them. So if so we do teach that. We do got a number of videos on that too. So anybody that doesn't have a dish that just wants to process these large, the large telescope data, that is very doable. So let's see what else we got. Okay. And by the way, how do we get this turned into a Drake's Lounge? Well, once a year we have a meeting at Green Bank, and Frank Drake, who developed the Drake's equation on how many civilizations in the galaxy, developed that in the bunk room dorm at Green Bank. And so and there's a little conference area, kitchen in there. So he's got the Drake's equation in there. And so after all our meetings, we go sit up there and we chat and we have a good time and share, stories about how the pulsars got away and things like that. And so we decided when the COVID thing hit, we couldn't meet anymore. We'd have a virtual Drake's Lounge. And so that's we have that on the third Sunday of the month. And you guys are now going to be hooked up into this time slot every month. And we also got a radio telescope observation party, which is the first Sunday of the month. And the purpose of that is to get we normally get too technical on the Drake's Lounge. Everybody talks about how to set up a filter, things like that, but we never really talk about the astronomy part and how to do observing. So that's the purpose of the R.top, is to limit us to the how to do observing and how to do that kind of stuff. So so that's sort of what we've got set up, and how you guys get involved. Paul reached out and said, "Hey, we want to play," and we got a bunch of great radio astronomers down here, and the time zones seem to have did us in the past, so we're going to fix that with this meeting, and hopefully this is a good time slot for you guys.
Seems to work well, Rich. Got a good turnout. I wonder whether I would just introduce people at this end.
Go for it.
Perhaps hand over to Phil. Phil, if you want to, in a moment, give us a quick rundown of the ASV. I invited a few extras, as well as our Astronomical Society of Victoria, and I can see Andrew.klekociuk there in Tasmania. Andrew and I have communicated over the years about various things, but we've never actually met. We've never actually even seen one another, Andrew. So this is a new experience. So welcome, Andrew, and I think you'll have information to contribute and learn from the others as well. Roger Heap, you're in New South Wales, I think. Is that right? Yep. And we were hoping that someone from the South Australia Astronomical Society might join us as well. So I know that they've got radio astronomy groups which can grow. So we're hoping that we might engender some interest in radio astronomy more in New South Wales and in South Australia. And Andrew, I don't know whether there is a group in Tasmania, an astronomy group, but we can include them as well. Yep. Is there one based in Hobart?
Yeah, Astronomical Society of Tasmania, and I'm a member of that group, and we have had a radio astronomy subcommittee that's been active at various times. I think it's not so active at the moment.
So that's the general background, and then we've got LMRO, Leon Moe Radio Observatory, which is based at our dark sky site just out of Melbourne. It's about 2 hours drive. Well, depending on where you are in Melbourne, it's 2 hours for me. A great location, designated dark sky site for the optical people. And you can see our dish in the background behind the guys there on the deck. And I'll hand over to Phil, if that's all right. Just give us a quick rundown of what we've got running at LMRO. You're on mute, Phil. Still on mute. Great. Oh, there we go.
Yeah. We put that on mute. Hello, everybody. I'm Philip Costigan. I'm the section director for the Radio Astronomy section for the Astronomical Society of Victoria. As Paul pointed out, we're here at the Leon Mao Radio Observatory, which is a little corner of the Leon Mao Dark Sky site. Yeah, 2 hours north of Melbourne. It's pretty much the centre of Victoria, so it's reasonably easy to find on the map. This site's been set up for the last 14, 15 years.
Yeah, the site has.
Yeah.
The radio dishes.
And we've been adding different projects to the site over that time. Starting with a radio Jove antenna, and then adding with things like even seismometers and weather stations and the like. And eventually, as you can see in the back, we've installed our 8.5 meter dish, which is been one of our projects that's taken almost 10 years for us to put together, but mostly put together with volunteer effort and the occasional help from different manufacturers for the more difficult parts. We've also got the Ecalisto antenna, a Whistler receiver set down at the it's audio amplifier, isn't it? Yeah, Whistler audio with an antenna. That's streaming live. A lot of our equipment is streaming live for the world to see. Yep. Yeah, there's about 12 different projects running full time, streaming the whole time. But we are looking to improve all the time. There's always improvements to be done. A lot of effort. Currently, our dish has only got a neutral hydrogen receiver up there, but we do plan to put multiple receiving systems ultimately, so we can use it for multiple purposes.
Yeah, as Rich suggested, we've got a smaller receiver horn there. We're going to put the hydrogen detector on that and reassign the big dish to other projects. Part of the charter of the Astronomical Society is the education of the public on astronomy. So and me, they're going to educate me. I'm a carpenter. So yeah, a lot of our effort is not just for purely our self-satisfaction and interest. It's also we set things up for demonstrations and education purposes as well. Yeah. So that pretty much rounds us off. Lot to learn though. We're novices completely particularly with neutral hydrogen studies. And how to get the most out of our equipment. The dish antenna we've got there at that frequency is about 1.7 degree beam width. Now, I was very interested in your comments there, Rich, about having a narrow beam width not being so useful for neutral hydrogen. That's the first time I've heard of that. So I'm curious about that comment. And I'm wondering a lot of things about how we can enhance the performance of what we're actually measuring. So there's so much that we don't understand yet. Yeah, Phil's a software guy. I'm a retired electronics engineer and a radio ham. And I'm a carpenter, so we struggle a bit sometimes technically. Communicating with each other.
And I'm a physics teacher, so I understand the physics, but not the engineering.
It's actually a good group because we have all this different gamut of people and we all come together and put our heads together and make things happen. It's good fun.
I think it's worth saying. Right.
Oh, just one last comment there, Paul. A lot of equipment we build too is our own custom design.
And we're trying to be as scientific as we can. This laboratory here, which you can see behind us, it's a converted shipping container. And inside that is a Faraday cage. So all of our computing and noisy equipment's in there. So we stop that radiating RF into the field out here. But a lot of equipment we design ourselves. And we've also tried to be precise with our collection of any data that makes it scientific. So there's a very, very accurate time-based system in the system as well. So anything that we stream online, we're planning to synchronize that with a time base. So any event that we capture is scientifically repeatable.
Nice setup.
Thank you.
Yeah.
I was going to just add in that today it's the barbecue. What do they call it, Phil? Barbecue?
It's the Christmas barbecue.
Yeah, so it's open to the public. So Phil and his merry crew there will be demonstrating the system for the rest of the day and into the evening, possibly even there'll be optical stuff going on overnight, I think, Phil.
Yes.
So there's accommodation up at that site. People can stay, but it's open to the public today. One of a number of public sessions. Well, that's a good shot.
That's from a drone that's being operated live now.
Wow. Yeah, that's a great shot.
You can see the dusty, dry grass of the Australian back bush country in the summertime or late spring.
Yeah, that big shed there is the Jim Trainer Observatory. It's a roll-off observatory, so the roof rolls off and there's some big telescopes in under there.
And the next one, the little smaller one next to it, is another recent addition. It's another roll-off roof, and inside there is an all abilities access telescope, something else that the Astronomy Society has tried to concentrate on, so that you can roll up a wheelchair to that instrument and you don't have to climb a ladder and things like that. This is a Naismith type of optical telescope, so you're looking in at the pivot axis, and that's always at a fixed height. So that's a new addition to our facility.
Wow, nice. You guys got those remoted from internet?
There are plans. Yeah, there are plans to hook them up, but we're not quite there yet. So a lot of things on the boil. Yes.
The radio dish is remotely controlled.
Oh yes, yes. We can certainly dial into the dish and move it around and download the receiver measurements as well.
Nice. Okay.
You see the big dish. You see the horn just on the right there, next to the building.
Is that azimuth elevation control, or is that just a? That's
just a manual, a live demonstration using a different technology for an antenna system. We've just fired that up for the first time today or this weekend. It seems to work. Thank goodness for that. So we'll have two neutral hydrogen demonstrations this afternoon, one coming off the dish and another one coming off that small horn antenna. Oh. This whole property around the dish, by the way, there's a myriad of underground conduits and cables, and a lot of, apart from using some machinery, there was also a lot of manual labour digging trenches that went on for weeks. So we built up some muscles there, Rich.
See the E-Callisto antenna there, tracking the sun.
Yeah. Nice.
That's a log periodic antenna. It automatically moves every few minutes, tracks the sun. That's streaming online to that international system as well. We're trying to concentrate a lot on citizen science, aren't we, Phil?
Yeah, so that's the intention.
We've got the lightning detector, the Blitzertung, that's on streaming online on the international network. We've recently
also has a Radio Jove, yeah.
The Radio Jove is available. Also, a most recent addition was an environmental
radiation
measurement along with a radiation detector, and that's part of a global system. So if you want to see the outcome of Vladimir Putin's nuclear Armageddon, we'll be able to get the remnant of detection down here from that.
I hope it's the remnant.
That drone shot is really good. I haven't seen it from that angle before. We're very lucky to have Lee with us. I think Lee's driving that, is it, Phil?
Yeah,
Correct,
he's
yes.
currently over there doing that.
Lee Green.
You can see Lee's van there. Lee's van is full of goodies, and he takes it to all the events and sets up optical, radio, the whole lot. So great stuff.
Unfortunately, it generates quite a lot of noise too, Paul. But when the star parties are on, we sort of turn a blind eye to a lot of interference and light pollution and all sorts of phenomena.
Yes, that's one of our biggest challenges. Is as soon as there's a star party, thousands of people, well, hundreds of people turn up and turn on all their switch mode power supplies to their laptops and
mobile phones.
and mobile phones, everything turns on. So our view of the hydrogen line becomes a picket fence of noise, which is a pity. But yes, star parties are just for enjoyment. No science done.
You mentioned an interferometer. We're planning to get one very soon. Yes. We've already got the receiver, and we're going to be picking up 2 satellite dishes that go with it. And we've got a much larger property here, so we'll look at ways of separating those 2 dishes as far as we can to get an interferometer system going. That's a learning experience for us too. None of us have got experience in how to get that technology working and make sense of the results. So that'll be another challenge for us all.
Yeah.
I imagine in the coming months that we may try or aim to look at setting up a project that uses interferometry between the US and Australia or something along those lines. That would be really interesting. But that's in the coming months and years, I would imagine.
The key is the timing. So we've got to get the timing, as Steve says, we've got to get that timing right.
Correct.
There is the Victorian Space Science Education Centre runs a dish in Tallarupville, which might be a good one to join up with in the first instance. I don't know, not quite sure how far Tallaruk is. It's probably within 50k or something, is it?
Very close. East of Leon Mel,
Yeah, so that would be a good one to join up with once we've got the timing in, just to try out, on a relatively short baseline. And then I know that there are these extra dishes coming in. So someone said in chat, what's it called, 20M? Steve, I think.
20-meter dish, yes.
20-meter dish, yeah.
In Skynet. So there are a couple more dishes going in Australia. So we might be able to tap into that. It's US only at the moment, but we're certainly waiting to see what might develop in that area. Andrew.klekociuk, have you got a quick overview of your setup there? Because I know you're quite well equipped as well.
Yeah, thanks, Paul, and thanks for inviting me along. Just a quick note, I started out in radio astronomy many years ago. I'm 61 now and almost retired. I'm taking my long service before I retire next year. I started out doing things from my backyard, then went on to do a PhD in physics with a thesis in pulsar timing. So I spent a lot of time looking at the velar pulsar and looking for glitches in the velar pulsar, and along the way did things in low frequency radio astronomy. My supervisor was Bill Ellis, who was a pioneer in low frequency radio astronomy, and I've published with Bill and also with Grote Reber, who of course was a pioneer in radio astronomy. So that was a really good start, and we got involved in things like space shuttle experiments and looking for Jupiter bursts and solar bursts and the standard things. And I kind of kept it up in my backyard. I went on to do work in atmospheric physics in the Antarctic, hence the background here. But I've kept contact with a variety of folks, particularly in Tasmania, which still has a very strong radio astronomy group, and they've gone off to do all sorts of amazing things. They've got dishes distributed across the country now. 26-metre dish I helped establish here. We have a 15-metre dish that I did my pulsar timing on. But in my backyard, I kind of kept things going and tried to emulate some of the, I guess, some of the capabilities that the group had in the early days. We did a lot of work in high time and high frequency resolution observations of solar bursts and Jupiter bursts. So with the coming of software defined radios, I've been trying to achieve some of the precision and resolution that that group achieved way back using much simpler technology. But I do things like meteor measurements that Paul and I have been discussing over the years. I have a few different antennas here. I'm in a semi-rural area and suffer from interference quite a lot, but a few different antennas that I use for Jupiter and the Sun. I have a Blitzortung station also, and I guess I've also gone down the route of putting in different sensors, infrasound, weather, etc., and trying to develop a few things that school groups could use, and trying to get the local astronomical society keen on also fostering some of that. But it's an exciting time now with in radio astronomy, and there's all sorts of areas that still amateurs can make a strong contribution to, and I'm really impressed to see the LMRO Observatory there and the capabilities of SARA as well. I guess I'm hoping to get more involved in getting back into the amateur side of things once I retire, and I guess with developments like the SKA and LOFA, low frequency radio astronomy capabilities, there's now the potential of borrowing some of that technology. I think some of the antennas that have been developed, the broadband low frequency antennas, would be well suited for distributed use by amateurs and making a contribution to various studies. Fast radio bursts too are an area that I think amateurs could potentially contribute to. Some of them are fairly bright and within the capabilities of amateur detection. So I'm very keen to, well, help out where I can and provide, you know, some information on my setup, but also to learn a lot about what other folks are doing. So that's a quick summary of me.
Thank you, Andrew. I think we've got hold of you just at the right time. If you're about to retire, you'll have
Yep.
have all that knowledge and all that spare time to put it to good use. So that's great stuff. And just a quick, Roger, just a quick overview of your end in New South Wales. I know you've got a very small group, and then Rich, we might come back to you, and we'll see where we go next. Thanks, Roger.
Yeah, thanks. Yeah, thanks, Paul. Yeah, sorry, I've lost you guys a couple of times here. I've actually, as I explained earlier, I'm on Starlink, paying good old Elon Musk for his service. And unfortunately, I don't know if you are aware, but you need to have a good southern horizon for it to work properly. Otherwise, the swarm of satellites goes behind trees and you lose it. So I've caught most of what you're saying there, but not all of it. That's dropped out at least once. But anyway, yeah, we've got a, well, by the way, I'm r.heap. I am now retired, sort of. You know, I have an old friend that told me the best way to retire is not to retire, and I sort of am following that advice. Really, got lots of hobbies. But anyway, I started with telecom in 1978. So I did a trainee. Did a little bit at university, which I didn't complete, and then I went on to become a technical officer with telecom, mainly fixing electromechanical changes back in the days when you actually had to fix them, not just change out cards. Went from there. Telecom eventually got privatized, so I started doing a bit of my own work, and the last job that I had was at the
I was like, Elon Musk has just dropped the ball.
Control systems technician.
Yes, but yeah, you're dropping in and out a little bit, Roger. But
your internet connection is unstable.
Yeah.
Can you still hear? It sort of comes and goes a bit.
It's coming and going, Roger. just quickly then on the New South Wales group, on your society, what's happening there?
Well, as far as radio goes, probably not a lot. We've had a couple of starts over the years, but it's never really got to any level. We actually have a dish. It's one of the old FLIRS dishes. I don't know if you're familiar with the history of Australia, but at FLIRS in the south of New South Wales, there was, I think they called it it was one of the crosses. But anyway, it had about 20 odd 5-meter dishes. I think they are 5 or 6 meter dishes that were controlled really quite interestingly, but yeah, pretty primitive for these days. So we've got one of those dishes, but we've never really been able to get a decent receiving system for it, or antennas to, for the LNA type of things. So it's never really come to much. So we have got a couple of members now who have got some of the kits for the hydrogen line. So there is certainly interest there in things happening. But one of our problems we've got is we don't actually have a mains power system. So everything is sort of solar powered, which in this day and age is not necessarily a problem, but there isn't the investment there to drive anything of the size that you've got there. That could change. Who knows? We ended up getting more involved in it. But at the moment, our dark sky site is at, we call it Wirrina. It's near Ilford, sort of north of Bathurst and west of Newcastle, which is, I live in Rylstone, which is the nearest town. It's about 50 kilometres away. I also live out of town. I've got my own sort of dark sky site here. I'm on 100 acres out of Rylstone. We're on the edge of the Blue Mountain, western edge of the Blue Mountains. Anybody that's familiar with Bathurst is sort of similar, but we're probably more in the Lithgow type of geology. So we're still in the mountains instead of, tablelands, but the Great Divide is only a couple of kilometres to the east of us. So I think we have a good, grounding here, but we've never really got to the same level as you guys have for various reasons. My interest has always been in the radio side of it. Originally, I'm from South Australia, so I have contacts over in South Australia. I've got relatives who came from the Broken Hill, Wilcannia area, which is probably one of the remaining relatively radio quiet areas in the country. And so I've always been more interested in because we don't have power at our site, in getting more portable systems going. So like a small interferometry setup. So at the moment, I'm setting up a 1.8 meter dish. And I've got to say, a bit of an aside there. The other thing that happens in our local area here, we have a contemporary arts festival. So one of the guys that was at the last one last year does things with synthesizers, and he moves things. He does, light displays, moves mirrors. I don't know if you're all into contemporary arts. It's all a bit out there. But we were talking about possibly hooking it to my 1.8 meter dish to get noises. And as we all know, you get all sorts of noises, probably demodulate it just with an AM demodulator so that it makes funny noises, and we feed that into his system to move things. So that's one of my little projects at the moment. So at the moment, I'm more interested in working in small dishes. I would like to get, say, a 3 or 5 1.8 meter dishes, hook them together in a portable setup, say 100 meters apart, get them to work in an interferometry type of setup, and then take them somewhere, take them to Wilcannia or Tibooburra, one of those sort of places, possibly then be able to hook them up with other systems such as your systems or other portable ones. And we go out for a week, and we go to 4 or 5 different places around the country, set up these small systems and hook them together to try and reduce our beam width, basically do the aperture synthesis with interferometry. Would be my that would be my final, well, not final, that would be my aim to be doing at the moment. It's what I've been trying to aim for years. So I was saying before, one of my pet things to try and find is the Vela pulsar, and I'm pretty sure I have detected it briefly a couple of times. It's circumpolar from where we are, as is most of Australia. It's a reasonably bright source as far as pulsars go, easy to detect. So yeah, that's basically my part of it, I suppose. we're still in the beginning, and I'm really happy to see the the Victorian people. We must keep in touch, try and get a bit of a cross-pollination as such happening there to get it to happen. And as
So,
I say,
Roger,
originally from South Australia. Yeah.
Just a quick one on that VLA detection. Just curious about the receiving frequency that you use to get that detection of the pulsar.
Well, it develops its maximum power around 400 megahertz, and it's a broadband.
Right.
It's a broadband service, and that's part of the reason that I want to do it, because 400 megahertz is well within, good old-fashioned TV antenna technology, and that's all I've been using. I've got an old satellite detector TV terrestrial analog satellite receiver that I did the detection on it before. So basically, that's part of the whole amateur thing, as far as I'm concerned, is to, try and get things made as cheaply as possible, buy as many people as possible in as many places as possible, and be able to hook them all together. These days, using the internet it means we need to get all the timing right. But there's GPSs have pretty good timing systems that allows some amount of synchronization. We've just got to get all of that right and get it together probably in one spot to process it all.
Yeah, so, fabulous. Thank you for that. Much appreciated. That's something I certainly would like to see on our dish, a 400 meg system up there.
Yeah, and that's it's within the capability of most amateurs. That I know the professional ones are going up into many of gigahertz, and that starts getting much more complicated, much more expensive, much rarer than the stuff you can go down to your local TV shop and buy.
You guys should be able to get the Vela with your 1420 with that dish easily. So I'd
but you need a
recommend.
fast receiver. You need to be able to detect the pulses, because it's very quick, isn't it? So you can't have a slow integration time.
Yeah, you need to have a GPS timer,
right,
a receiver.
So that's 11 times.
Yeah, it's all about the back end.
I'm losing you again. We've got to blame Elon Musk.
So Rich, just give me a pointer on that pulsar detection method.
Well, one is your dish is, if you have if that a 1420 feet on there, your dish is just fine. I wouldn't even worry about modifying that. It's on the receiver side, and the processing, and the software processing, and you really need to. We've got a number of videos on that. We've got and Wolfgang Herrmann's online. He is by the way, he's probably the only amateur to detect FRBs, and he's doing it regularly now. So if you see some of his videos on that, and he's just got another I think his second FRB type in the last couple of months. So he's really sort of the number one expert. Our group is only we have 24, and we're ranked number 3 in the amateur group, but he's really the expert with like 130. Anyway, get the software, get the GPS timing, and the receiver set up. And our equivalent is the B0329 plus 54 on the northern hemisphere, and that's our brightest. And that's it took us a long time to figure out how to get that one. And it wasn't because we weren't seeing it, it's because we weren't figuring out how to process it. So
it's not like. So you're not like you're going to just point the dish to this object and you'll hear it in the speaker in real time.
No, you won't. No, you're
okay.
Pulsars are their blips are underneath the noise floor. So what you have to do is you have to fold, basically have to overlay the all those pulses on top of each other until they build up, and the noise being
correlation function.
Yeah, well, and the noise cancels itself out, so the noise stays about where it's at, and you're overlaying the pulses until they peak above the noise, gotcha. And then you can pick them up. And then you have to use software like Presto to actually detect it, and if you don't have Presto, and what I find is a lot of people sit there and they try to show me a pulsar on a graph, but they just show me a peak, which doesn't tell me a lot, except that there's a pulse there, but it could be RFI. But if you use Presto, the software, which is really the standard, has about 4 or 5 different outputs that once you correlate all those things, you can very well tell it's a pulsar or not. And we got enough pulsar people that do pulsars here that if you actually think you've got a pulsar, before you declare you've actually got one, send it to us and we'll give you some. We'll give you sort of hey, yeah, that we think that's that or it's not, and that'll save you a lot of, because the number of false positives I had were tremendous. I had so many false positives on pulsars that until I finally started getting them regularly, I didn't trust any of them. But we got a lot of experts that can give you that, and then give you advice on how to tune it up and until you get the next one.
Well, that's great advice. So we shouldn't just jump to 400 megahertz yet. We could still use the 1420.
Oh, absolutely. You're so, Vela is so bright that's perfectly fine for. In fact, we most of our pulsars we're getting now are at 1230 megahertz. We were doing at 400, then we went to 1420. Just depending on what feed we got up, we basically use almost every feed, and then the pulsars are usually bright enough. And by the way, Vela you probably don't have to track because you could probably just pick it up the first time, but most of the pulsars you're gonna have to track. A lot of our pulsars were at the 2 to 3 hours tracking to get enough content. I think Wolfgang does it really fast with his. He doesn't have to track a lot, but he's still tracking. So you need a tracking antenna if you're going to do a lot of pulsars.
Well, we've got one of those for sure.
Oh, perfect.
One of the other things you can do, of course, is if you've got a fairly broad bandwidth, you can de-disperse to enhance the signal to noise. And that's the sort of thing that we did a lot of in our pulsar work. So I think that Presto software actually does de-dispersion as well as folding. Yeah, and that's the technique. Basically, you record a lot of IQ raw data, and then you fold and process. So that would be quite well within the capabilities of that dish that you've got there. We used a 15-meter dish. We could see the large pulses from Vela quite easily, but I think a 5-meter would be fine at 400 to 1.6 gigs or something like that.
Yeah, I think
thank you, guys.
Yeah, I think one of our biggest problem we had with that 60-foot dish was accurate pointing. We basically, you've got such a narrow wind with as we're saying, larger dishes aren't necessarily always best, especially if you don't have your pointing figured out, because you're so tight on pointing, you can easily miss the object. So until we got our pointing, down very precisely, we were missing even our brightest pulsars. And then once we got that down, we were starting to pick up pulsars again. I think Wolfgang's he's got the biggest dish, I think, with 85 foot, and he's got pointing down very, very tightly.
One of the scientific advantages in looking at these pulsars is monitoring for interesting events. So glitches are obviously one. You need good timing for that, but just variations in dispersion measure and rotation measure in the line of sight to the pulsar is something that amateurs could potentially contribute to. The University of Tasmania here still monitors the Vela pulsar continuously, and so there's some good opportunities there for comparing your results to see if you're measuring the same thing, but then potentially if they stop their program, you could take over or even assist with that as well. So there could be some other opportunities there.
Yeah, and I believe Steve Olney, who's down in Sydney with you guys, he couldn't be on today, but he's got a automated monitoring of the Vela, and he's picked up two glitches with it as an amateur. So I would recommend that you look at his site, especially if you're going to set up an amateur detection of Vela, because he's got a fixed antenna. I think he's got a corner reflector, and he's got a quad
a quad Yagi. Yeah.
Yeah. And all right, let's see. Well, Wolfgang, now that you're on, you want to, I don't know, Paul, you got it? Got any more introductions? And I thought we'd go, we've got about 3 different sites represented here from the Northern Hemisphere. And do you got any more on the Southern Hemisphere there?
That's all the intros. Oh, Blair, sorry, Blair's there. Yes, you're in South Australia, Blair, is that right?
Thank you very much for inviting us. I'm the coordinator in South Australia for our little group. We've got reasonable talent as far as technical staff go, but there's only like 4 of us. We have a quiet site, relatively quiet, but we've got a Callisto project up and running on for solar outbursts, and we're very happy with the results we get out of that. We're getting up around the same number of detections as Arecibo do on their site, so we're providing some reasonably good data there. We have an interest in seismology as well, and we sort of run the whole seismic network in South Australia. But as far as the radio goes, we have one member that's got a 6-meter dish. He's doing some Vela work. He's the ex-director from the Molongo radio telescope, so he sort of knows what he's doing. We have a couple of other people that are doing, just starting to put together some SIDS monitoring stuff in VLF. That's probably about it. If you want to go and have a look at our site, assa.org.au, resources and the radio astronomy section there, we've got quite a bit there. If I can share a screen, hang on, I've got a picture here somewhere. Hang on, I'm just trying to find where I hit it.
Just while Blair's doing that, it's worth putting any information, links and names and so on into chat, so that people can grab those details. Steve, I think you've got a few links there you'd like to follow up, certainly. Blair, you ready with the share?
Yeah, that one. So that's our, can you see that one? Yeah, okay, so that's our site at Nil Dotty. So it's above the high tide mark on the River Murray, quite important. You can see all the limestone. We've built a low frequency MWA antenna, works extremely well. In the back's solar tracking log periodic, which does our VHF side of it. It's all solar powered. Bit of a close up there. This has worked out really well. If anyone wants to do some low frequency stuff, sort of 20 to 100 megs, this is absolutely superb as far as a thing goes. There's the setup that we've got there, and the sort of level of work that one of my colleagues does. He's ex-defence. You'd expect nothing less from someone in that sort of thing. So yeah, we're fairly happy. That was the early days. We built that. We used linear actuators to track. It worked really, really well, but it tends to track bright clouds as well. So we don't tend to do that. We're about to change this and replace it with a MWA VHF antenna, which we've got built, and it's all up and running. That's probably it for us at this point in time. I'll put up a link to that in chat somehow or other.
Just got a quick question. That's obviously a remote site. Is that streaming online for you?
It's not. Not so much streaming online. Every 15 minutes, the software of the 3 receivers generates FITS files, which are then sent off to Christian Monstein. It's then stored along with everyone else. So we have regular data that goes off there. It's been up and running for about 4 years, and we regularly become the most number of outbursts. So it's a lovely site, and it's we're really happy with the results. The biggest problem we've got is if you're using Windows computers, is keeping them up from all the ruddy updates. And the Linux stuff just doesn't seem to be overly super reliable. But we've worked a lot with Whit Reeves in Alaska, sorting that out, and we've got it down pretty pat. We're fairly happy with it. If you want to see some really good outbursts, go and have a look through the data. I'll put up a link to some of our stuff, and you can get everything off that. All right, thank you.
Thank you.
Thank you, Blair. Thanks, Blair. Well, Rich, you've got quite a range. We've got 4 states represented then, which is a pretty good effort for the first time round. We do have other states in Australia. We'll see if we can get them involved as well. But and the other thing I'll just throw in from my point of view as a physics teacher, I'm presenting at a number of conferences over the next few weeks and months about astronomy that can be done at school during a school day, so not necessarily waiting for dark and optical. That starts as something as simple as sundials, and the more you dig into sundials, the more maths you get involved with, and the more it's absolutely amazing area to get involved with. Through radio astronomy, Radio Jove, Callisto, all the online streams, they're all accessible. And then the paper finishes up with reference to the online optical, such as SLU, which is designed for schools, and the what do I mean? Such a nice, what are the one in Sweden? It's the SALSA, SALSA in Sweden, which is 3 radio telescopes, remotely operated, all for free. You just make the booking, make your observations, download the FITS, and away you go. Absolutely fantastic. So we're on the lookout for more online streaming services, radio telescopes, data services, whatever. And that'll all feed into this initiative to encourage schools to get involved through STEM programs. And then they can all become members of your astronomical society and or SARA. So that's where I'm heading with that. Back to you, Rich.
Well, that's great. You guys have a wonderful setup down there. I'm really impressed. This is excellent. So I'm going to start from like our small group and go up to I'll get Wolfgang last because he's got the most. But Ted Cline and Jay Wilson, Little Thompson Observatory in just north of Denver, Colorado. You go sort of give a quick overview of your site there and some of the stuff you're getting put together.
Let's see. Behind me, if that turns, I have to unpin. Okay. Behind me, we see a picture of 2 dishes there. One is 15 with a red stick on it by one ear, and the other ear has a 16-foot dish that is listening to 1420 on both of them in different ways. The one on the left has motors, the one on the right doesn't. So I use it for drift scans. It works great. Behind us, we also have a bunch of optical telescopes, how the institution began with the Little Thompson Observatory. I'll put a link in if it matters. And we're just learning all kinds of fun things, trying to figure the world out. I've been concentrating on software to try to analyze the 1420 megahertz emissions and organize them enough to plot them up on the sky. But I am surely learning in the process. How's that?
Okay, could you show some of those outputs because I think the
if I can push the right buttons. I will just keep talking and do it this way as opposed to try to share.
That works. And this for the ASV group, Ted's got a very good output of doing the heat maps there for your hydrogen.
So I've been trying here with, I think when I talk, it shows up. Maybe I have to close this down. So there's a globe of the galaxy, I guess, and it isn't perfectly a horizontal line because of some timing issues. And I think this was Pablo's data, actually. So yeah.
Galactic coordinates.
Did I say it wrong? Okay, galactic.
Exactly. That's galactic coordinates, yeah. And then, by the way, the white part is the southern hemisphere, which we're missing.
Yeah, we need you.
Come to the right place. Steve, onto it. Steve at LMRO, that's your aim. Fill in that white circle.
Yeah, of course. I'll do it by hand. It'll come in good time, folks.
Yeah.
Anything else, Ed?
I think that covers it.
Yeah.
Should I put up the link to that software? Is that what you want me to do as well?
Well, sure. Share as much as you want.
Okay, sounds good. Thanks very much, gentlemen. I'm fascinated to see what you're doing. I would appreciate links in the bottom. I've got 2 sites now, but there are 4, so keep them coming. Great.
All right. Let's see. Steve Tzikas, you want to go over sort of our 20-meter telescope program? Steve, you there?
Yes, I'm here. I'm just trying to get my video working.
Okay.
We have a 20-meter radio program. It's at Green Bank, and it's usually got a L-band receiver on it. Once in a while, X-band. It's totally remote. It's part of the Skynet network, which also has optical telescopes. There are some plans to expand it, I think up to 7 telescopes worldwide. 2 are in Australia. It's US citizens at the moment. If you want to look at the data, I maintain a analytical section page on the SARA website. So if you go to that, I've got a link there, and that'll allow you to see the data from the 20-meter radio telescope. So those who don't have an account, all the data from other observations, that's all public information. You can scroll through it. I think it goes back to about 2014. It's got different modes, high resolution, low resolution, pulsars. So you can just browse through that data. There's a whole assortment of quality in there from professionals to students. But you'll get a feel for what you can do with the 20-meter. I'm trying to learn something new every year with it. So when we meet at SARA, or recently through the virtual conferences, give a demo on the 20-meter and what you can do with it. So last year, or this past August, was some raster scans. Before that, I did some observations with masers, and before that also pulsars and hydrogen observing. So there's a lot you can do with that. You'll see my prior PowerPoint presentations on the demo there too. So one of the things we like to do when we meet at Green Bank is the 20-meter operates in real time. There's really no queue to it unless it's down for maintenance. So we can type in some coordinates, and you can actually see the radio telescope move outside where we meet at Green Bank. So that's good. The other thing at the Green Bank site, which SARA members have access to, is the 40-foot radio telescope. So that's not remote. You have to be there for that, but that's a lot of fun too. So that's about it on the 20-meter program. There's always a lot to learn. So I've been, that's my favorite instrument. I've been learning the last few years, and there's still a lot to learn. So it's been keeping me busy.
And Steve runs the analytical section. If you go to the website, there's a whole analytical section. It's about any kind of radio observing you wanted. It has a lot of detail on how to set up and for various astronomical objects, masers, pulsars, hydrogen, various other things. So that's a good place to start too. All right, thanks. Don Latham, did you want to give an overview of Deep Space Exploration Society?
Oh boy. Well, let's see. I'm a few hundred miles away from it, but DSES has a site at Haswell, Colorado, out in the middle of a cornfield, and it's pretty quiet. We have a 60-foot dish, as we've talked about. There are various HF stations there for amateur radio. It's at the minute a lot of ham radio going on at the site. 1296 and 400 megahertz 70 centimeter moon bounce, just finished moon bounce, and also in between looking to expand our capability to do pulsars and hoping to catch some Furbies, but who knows. Fellow named Dan Lane has been doing most of the work currently, along with a few others on the pulsar catching, and he's probably as up to date as almost anybody, except perhaps for the folks at Wolfgang's outfit, on handling the software. It's not easy. It's not terrifically hard, but it's not easy either. And I think if you're not a programmer, you may have some real trouble getting that software going. At least that's what I see from my viewpoint here in Montana. I have a 16-foot dish, which is just sitting right now, trying to get ready for 1296. I may try for a pulsar or two, but I don't know. I may not have the patience for it, or the accuracy in pointing, which is simply paramount. You've got to know where you're looking. And that's about all I got to say. There are several people that simply actively work. Maintaining a 60-foot dish is not a joke. It takes constant effort and a lot of folks. And especially since these are old troposcatter dishes from the early days of satellite communications, like 1957. My own pedestal for my dish is left over from the Tyros, the first television weather satellite system. It came out of the South Pacific and it's pretty corroded, but it still functions pretty well. Outside of that, I don't know. I probably missed some stuff, Rich. We've got, let's see, isn't there a Jove, Radio Jove on the site now? And we're trying to get ready to put up a,
we got a 1420 megahertz interferometer. We got 5 acres of land, so we got a pretty good stretch we could put it on. And they just got a grant to put a building on the site. Now we do relate to the fact that I think, Roger, you didn't have any power for the first 10 years. We were running on solar and generators for the 60-foot dish even. And we had to turn the generator on to move the dish. And finally we got some shore power, some real power, and So we're very good at solar and batteries for keeping the site up. So we can relate. Okay. Hey, thanks, Don.
Yeah, that's right.
Let me see what else.
I just make a comment there,
Rich.
We've
got 2 phase on this property.
We completely understand all the effort that you're going through to get things to go. We know that same path. We've had power issues, we've had all sorts of things, and yeah, it's humbling to see that everyone else is going through the same issues.
Everyone's human.
Yeah, it's good to know everyone's human.
Right.
But it has taken many years. But finally, our property here at Heathcote has now got 2 separate phases coming onto the block. So we're not sharing the radio astronomy phase with anybody else, as far as I know. So it's dedicated for our group. 1 phase for us and 1 phase for everybody else. And we've also got 240 volts here.
Yes. But yes, it's it's interesting to see that everybody's going through all the same struggles to get their things going, and we've gone through those too, so we completely understand.
Getting a 1957 drive system to run with modern electronics and a reasonable motor, if you can find one, if the one that's on it isn't totally destroyed and rusted out, is not trivial.
No, not at all.
Okay, let's see. I've got Jack Lobinger. Did you want to go over what the kind of system you got set up? And
yeah, let me share, see if I can correctly share a screen here. And we'll see what happens. Okay, I don't know if everybody can see this or not, but this is basically, I have a 3-meter dish, and I'm pretty much in an urban environment in Houston, Texas. And but I've got a 3-meter dish primarily doing hydrogen, looking at hydrogen, and also working on getting more pulsar capability put together. Now the screen, if you can see it, is actually a copy of, this is an active system that's running right now. And this is Jim Sky's Radio Sky, or Radio Eyes. And you can probably see here, this is the beam of my antenna. It's about 4.7 degrees. And this is a polar view. And this red outline that you see here is my visibility, because I've got so many neighbors with trees and things that I don't have a great deal of horizon to play with. But then the actual, as it's already been said, the actual must for doing pulsar type work is being able to accurately track. And this is my tracking software, and I'm in full control with the dish for positioning. I can jump to positions. I can also track, and that works with the encoders and the antenna sending data back then to the to this map, which is the beam is continuously positioned depending upon the antenna, so that's pretty much my end of things, but it's just sort of an ongoing effort to try to continually work with the software, and also try to get into the doing more capability with pulsars.
yeah, and Jack just put a YouTube video, which I recommend, on different coordinate systems. So if you don't understand ASL versus Earth horizon versus celestial versus galactic, then check out his YouTube video. Okay, great. Sarah, you're trying to get a system set up, and you're in a university. You want to go over sort of what you're planning on doing? We can't hear you.
No.
No, we can't hear you, Sarah. You're off mute, but I can't hear you. No, sorry.
Two.
There you go.
Hear me now. Okay. About 5 years ago, we discovered an old raggedy leftover 2.5 meter dish and at the observatory at the University of Maryland. And the director of the university at the time wanted us just kind of mused and said, I wish we could get that to work, because it hadn't been working for like 30 years. And so I took it on, and we basically got preamps, and we use spectrum analyzers and tectronic spectrum analyzers, 36 dB preamps, and Yagi antenna set up above the dish, got it into focus. And so we're down to about minus 197 dB sensitivity. Of course, it's got a 10 dB wide arc, and it's just drifting through the so what we do is we look at the passage over the last 5 years. We've been just looking at the passage of the Milky Way, and that's predominantly what we're doing. But the other thing we do is we have another channel with another spectrum analyzer, same kind of sensitivity, and we're comparing the noise floor to the actual signal, and we're looking at that signal to noise ratio. And what interests us is the actual interference and how we can gradually increase our sensitivity above the noise floor. And we know the noise floor because we're actually measuring it. We actually have a whole channel dedicated to that. So we're gradually improving our sensitivity, and at a given point, COVID happened. We got shut out of the site, and then politics. So we no longer have access to the site. So we have about $20,000 worth of equipment just sitting there fallow. But who knows? You know, the gods may shine upon us, and we'll get another somebody or another who will appreciate what we're doing. So that's where we are.
All right. Well, we're planning on helping you use your equipment if you can figure that out.
Okie dokie. We're sure we'll look forward to it.
Hey, Pablo, can you give a because you really did a lot of work on your system in California.
Well, the first thing I want to say is that I'm shocked. I am shocked that it's already Saturday morning in Australia, okay? Which goes to prove, I think that there's a theory that I'm developing here that the Earth may not be flat, but it may be round. I think we can prove that here. And that's why the Australians are always way ahead of us in every respect. Basically, I have my 2.1 meter working right now. Let me share my screen. Just gathering data with it. My next project is to get a tracking mount, and I don't know where that's going. I guess I'm going to have to spend the money so that I can get my first pulsar. But basically, that's pretty much all I'm doing right now with radio astronomy.
Can you explain what the hookup is on that? Because I think you showed it, and these guys are trying to get hydrogen set up, and so what kind of receiver and et cetera.
Okay, this is the typical SDR, the standard one.
RTL SDR.
Yeah.
SDR sharp.
Right, and I have two LNAs in series. I have two NULX, or NOLX, I don't know how you pronounce it, in series, basically giving me a minus 25 dB gain. This dish right here, this is a live feed of the dish. This mount I created myself from spare parts, and I can reposition it, but I cannot track with it. But I can point it in different directions. and get data. So that's pretty much it.
And right now you're picking up the galaxy because I see your
right now. Yeah, and I'm making with Chronolapse. I'm making videos with it right here. It's going to take a while. I don't know why it's taking a while for the folder to come up with the videos, but so I make videos, and you can get data with it. You can right here. You can get the data and export it to a program. I wasn't prepared to talk. Sorry about that, guys.
Oh no, that's fine.
I was just.
But I think that the key is that with a 2.1 meter dish, you can definitely get hydrogen data. You can get the Doppler on it. You can, and there's a number of videos we've got on how to actually use the Doppler collected data to figure out the rotation rate of the galaxy.
Yeah, Ted's got a program, fantastic program that it actually uses the data generated by this system, and it creates all the graphs. And in fact, he posted it already on the chat. Right. So, and it's geared for this SDR receiver software.
I just comment on IF average on that screen as well. IF average is a fantastic tool to pull things out of the noise.
This, by the way, this noise is the, I have a whispered transmitter, which is reaching Australia right now, 200 milliwatts. Yep. So that's why, and it's pretty close to the antenna. This dish is about it's about 50 meters behind me right now, and on my property, but it's 50 meters away. So that's what the noise is. And this one's probably from a Wi-Fi from this house. This is a neighbor's house. So, but the two LNAs in series actually eliminates most of the noise, and it increases the gain by 20 dBs. It actually works. And you don't have to have the specialized LNA. You can have a wide band LNA, which is only $19 US with the Sawbird. But I have two Sawbirds in series, and I'm getting tremendous amplitude out of a very basic system. Let me see if I can activate this here.
Those Sawbirds are a great bit of electronics.
Yeah.
Got one here.
I was going to try to, there we go. And I have this simple motor controller where, let's see, is this the, I don't know if that's the, I'm moving in that direction. Oh, there you go. I'm moving the dish right now with a very a linear motor, and as you can see, I can change the tilt. And which I haven't used in a long time. This is very simple. And we're talking about this whole system, $300, $400 with the motors and everything else. The computer, it's an old computer that I have right there in this doghouse, which, by the way, works fantastic even in the rain. It protects that computer because with these LNAs, you have to be very close to the computer because of the USB limitations. And I do have a very simple, let's see, is that it? No, that's it. I can actually tell what the elevation is, because I have a sensor that is attached to the dish, and I haven't tried this in a long time, so I don't know if it's going to work or not. But anyway, I don't want to take my, let's see. These sensors are only $35, and they're magnetic, and they're stabilized. They're gyro stabilized, so you can attach it to the dish, and it'll give you the heading and the inclination, the tilt. But this one's taking a long time. I don't want to take any more of your time. Oh, here we go. I haven't connected this in a long time. But with this sensor right here, and this is a airplane type display, you can tell what the angle is within a couple of degrees, or actually within a degree, and what the heading is. And it works really well. They're $35 on Amazon. So I can point this dish to any point with pretty good certainty. I had high wind, so the sensor's probably disconnected, but you get the idea. Anyway, that's all I have to say.
Thanks, Pablo. I think I got everybody. And Wolfgang, I didn't ask you to do a sort of a demo of your site, but if you could just sort of go over what your site has at AstroPeeler.
Yeah, I can show a few slides.
Okay.
Okay. Just make that full screen. Okay. You can see my screen, I hope?
Yes.
Good.
Okay. Just a quick overview. This is an aerial view of the site. There's a 25-meter dish in the foreground, and then in the background there's a 10-meter dish. This is just to give you a rough overview of the site, but let me just go to the different instruments. I'll skip that one. It's a little bit of history. So our main instrument is a 25-meter dish. It's equipped with an L-band receiver, so it's running from around 1230, and we can go up to 1700 megahertz. We also have some auxiliary antennas which are in UHF range, but due to the RFI situation, there's not many things that we can do in that range. So basically, it's an L-band instrument. And the second largest antenna that we have is a 10-meter dish, which is for higher frequencies. That's used in KU band and KA band. The prime application there is in the KU band. We look at mesas, at methanol mesas, and in the KA band again mesas, but these are water mesas then at 22 gigahertz. Then there are more L-band instruments. One is a 3-meter dish shown here, and a 2.3-meter dish. Some of you may recognize that actually is a refurbished SRT. So it's one of those MIT SRTs, which we have completely refurbished. So the only thing that's left over from the original SRT is the mechanics, the dish itself, but all the electronics is completely new. We can combine these two instruments. They're about 50 meters apart. We can combine those two into an interferometer, a two-dish interferometer. And then we have another interferometer, which is a 10-meter baseline. These two offset dishes, KU band instruments. The dish in the middle is the only dish that we have that is not used for astronomy. That's a standard TV dish. So this is non-astronomical, but these two 1.2 meter dishes are used as an interferometer. And then we have a 1.2 meter dish, again for L-band, that is for the hydrogen line, which is on a trailer, so we can haul it around. And the main purpose of that is to bring it to school so we can do little experiments with schools. So this is our zoo of dishes. And what we are doing with that is we have some long-term monitoring programs, which we are doing with our 25-meter dish. One is that we are monitoring one specific magnetar. It's one of the few radio loud magnetars, and we are now in, I think we are now two and a half years that we're observing that regularly. A lot of focus at the moment is on fast radio bursts. We do observations and monitoring of essentially two fast radio bursts, two bright fast radio bursts, which are repeaters, so we can continuously observe them. One is called R67, which has been quite radio loud, but it's silent right now again. And at the moment, we are concentrating on another, which is called R117. Another long-term monitoring program is looking at circumstellar OH masers at 1650, 1612 megahertz. And that's a program that's been running for almost 3 years now. So these are the long-term programs. And then, of course, we do a lot of things that sort of are of interest to us. Our members, they may have interest in various things. So things like radio recombination lines. Then, of course, we do pulsar observations. And then another area where we have some interest is hydrogen emission of nearby galaxies. So we're looking at other galaxies that's somewhere in the more or less vicinity, astronomically speaking. Then we have an area where we do educational support and outreach. So we have a support that we support bachelor and master thesis. So students come from universities and use our instruments to do measurements for their thesis. And we also do lab courses for different universities where students come to our place and then we spend the day doing observations. Another activity is that we do lab courses for schools. These can be either elder pupils which are doing a advanced course in physics, or also younger pupils where we do some more basic things. And we show, in general, we do show visitors around. So this is the thing that we do with our instruments. And essentially, in a summary, the ASSA it's in Germany. It's probably the largest amateur radio astronomy site that's operated by amateurs. We're cooperating in some scientific programs. At the moment, we are doing the FRB observations jointly with other instruments in various countries. So we are doing simultaneous operations in different frequency ranges. And as mentioned, we support master and bachelor thesis. Lab courses I have mentioned, and the outreach activities to the general public is an area. And I think the main driving thing is it's a lot of fun. We are doing this as amateurs. We're having a very advanced instrument, and there are, of course, lots of things to be done. It keeps us very busy, but it's a great lot of fun. And of course, if there are any questions, I'll be happy to give you some more background.
Go ahead. You guys got any questions?
Yeah, I'd like to know how he keeps that 10-meter surface of that 10-meter dish formed close enough to do the work he's doing.
Yeah, it's
Alexa.
At 22 gigahertz, things are becoming critical as far as surface accuracy is concerned. Actually, we do have some deformation of the dish and parts of the dish, so it's reducing our aperture efficiency there. For 12 gigahertz is pretty fine. We're okay with that, but we notice that, for example, if you look at the angular resolution that we have, it is not as good as it should be at 22 gigahertz. And that's an indication that we have some losses. We don't know exactly how much the deviation is, because we don't have at the moment the means and the facility to measure that. We're looking into that and see what we can do. But at the end of the day, it's a fairly old instrument. It was built in the 60s, and we have to live with its characteristics and do what can be done with it.
Forgive my ignorance, but what atom are you actually looking at 22 gigahertz?
Well, it's a water maser at 22 gigahertz.
Okay.
Water in the vicinity of certain stars get into an excited state where they actually emit as a maser, and that can be very strong.
Okay, thank you.
Oh, go ahead, Andrew. You got your hand up.
Oh, yeah, thanks. Yeah, Wolfgang, it's Andrew here. Just interested in what duty cycle you use for observing your FRBs. You know, what fraction of time are you actually looking for those? Thanks.
Well, at the moment, we're almost doing it 24/7. There's a specific FRB, which was detected by the Giant Telescope in September this year. And it all started with an astronomer's telegram in mid of October when they said they saw an enhanced activity. So we decided we should have a look. And actually within a few hours, we had our first burst from that FRB. And what we're doing at the moment is, well, we had a couple of days recently where we actually did it around the clock. We have now reduced it to 9 hours per day. We probably reduce it more and see how that FRB evolves. And there are two limiting factors as far as observation times is concerned. One is we have to have people on site that actually supervise the instrument. And another area of concern is power cost. I mean, if we are running the instrument full 24 hours, it's not only the mechanical drive, it's also the computers we have. In order to evaluate the data, we have fairly powerful computers, and they consume quite some power. So that's another limiting factor, especially when energy prices go up like they do at the moment. But we try to do as much observation time as possible right now.
Yep, thanks.
Rich, I'm aware of the LMRO people needing to set up for their public visiting. Phil and Steve, do you need to go at some point? Any questions?
I'm overwhelmed with questions, but no, you're quite right, Paul. We'll have to take a break soon for sure, and we've got a couple of things to do before the crowd turn up. So yes, it's been absolutely rewarding to join in with the team today. Learned a great deal, and we got some contacts there and some things to follow up. So it's been very rewarding. Thank you.
Stay as long as you can, Phil, and then just turn off.
Yeah.
When you're ready. But thanks to Lee for that drone footage as well. That was fantastic.
Well done, Lee.
I'm going to have to leave soon too.
Okay, Roger, thanks.
So yeah, I've got other things to go to. So it's been very rewarding. I'll be in touch with a few people. I'm sure there's some email addresses here, and I've got an awful lot of YouTubes to watch by the looks of it.
Yes, yes.
And yeah, and it's good to meet you guys. Hey, I think we can all get together here in the South and do things. That's good thing.
I want to come and ride the GAN.
Yeah, absolutely. I haven't been on it yet, but I've heard, yes, will be soon.
You can all come and visit.
Before you
a few more meetings like
Roger,
this, and we'll come up with some good stuff, I believe. Be worthwhile.
I think
you're planning more meetings. When will the next meetings happen?
Well, I've tentatively got this thing.
Dates. Go on. Sorry.
Well, I tentatively, in Zoom I could set it up for any time, but I've got it set up at the same time next month. So make it a monthly meeting, 9 o'clock your time, and it looks like it's okay, except for poor Wolfgang. What is it, like 2 in the morning there or something like that? He's probably the worst case of the group.
Yeah, it's not that
Germany,
bad. It's
so,
it's half hour after midnight. So
okay.
I'll go to bed anytime soon.
Yeah, it's 3 in the afternoon. It was 3 in the afternoon when I started, so that's perfect for me. So I can do this all day long. Yeah, I've got it set up monthly. That's your call if you guys find it. And you know, we basically, when we do it, you know, we have it. That'll be, you know, basically 3 times a month for us. We really get I mean, people sit there and they start asking detailed questions and stuff like that. And we have great conversations every month. So this is almost more formal than we normally do. Just going across the group here. So yeah, bring your problems and your ideas and your innovations and stuff like that, and hookups, and we'll do that. So I've currently got it scheduled. I'll go through Paul, and he'll, I guess, redistribute the link to you guys.
Yeah,
feel free to join SARA. You'll get it.
Yeah.
Yeah.
I was thinking, Rich, perhaps once every 3 months we do this big, everyone come along, and in the intervening months we could have a topic, a chosen topic. Someone put a yeah. We'll talk at this end, and I think I've got all the contact details so we can work it out. And we've got so many topics there. If we chose a particular topic, people come along to chew over that one, and then every 3 months we have the big get together, and we'll see how we go.
That's great. That'll work fine.
Do we have links for all the observatories that we spoke of today? I saw 2 out of Australia. Are there more that should be put in the chat?
Well, perhaps, Rich, can you do a collation and send it around?
Well, I don't know if I think what you're saying is we've got all of ours in there. Do you guys have all of yours on the chat? And
I think we did.
I saw the LMRO go up.
You've got ASSA, which is the South Australian. You've got Leon Moe, which is our Victorian one. Roger, have you got a link you can put in?
Sorry, I was on the phone there. It's that to the Astronomical Society.
Yeah, just
yes, we said
just in the chat, and then we've got all the links.
Okay.
Okay. Yeah, I can get one. There's the chat here. Okay. Oh, she'll put it in. I'll just put my email address in for the moment, and we'll work it from there.
Okay.
All right. Now I'm gonna I'll edit this a little bit, and then we'll put it on the YouTube channel, and so you guys and I'll even copy the chat area and make sure that's on the end, so we won't lose this stuff. Anybody who would like to write a paper, we have a SARA YouTube journal that, in fact, 12 December, I'm the journal editor also. So 12 December is when the thing for the next journal is due. We also have an observation section. So if you've got a 1 to 2 page observation of an astronomical object, we'd love to have those. That makes it easy for you guys to have little quick observation sessions. If you've got, I'm also looking for people who would like to do a little YouTube snippets of 5 minutes or so on a various technical topic, astronomical topic, something that we could just have a quick thing, and basically we set it up as a Zoom conference, and then I edit it and then we post it. So I'm looking for that. Those are educational little links, things like that. So all sorts of capability to communicate your ideas and your sites and your demos and things like that, we can help you with.
Very good. I put the Zoom link for my paper, Rich, that's coming. This is the international conference. Don't circulate that just for now. The conference is the first week in December. So once the conference has happened, that YouTube video will go public.
Great.
But anybody with the link at this stage, if you want to circulate just locally, people can have a look at that, see where I'm trying to get to.
Great.
Right,
okay.
Drop out.
Any other
Yep,
questions?
we're going to head off, guys. No more questions from this end. We're going to head off and start setting up for our party. But
Thanks,
thank you
guys.
very much. That was excellent. Thank you.
Sarah, before we go, did you have a question? You got your hand
Yeah, I just wanted to know what level did you want that YouTube snippets to be?
Any
beginner?
Well, I would say technical to advanced, just, little short ones to just cover a small piece of the whole system or the theory.
We could probably do that signal to noise studies that we did. That would probably be fun.
That'd be great stuff.
Actually, we had several students actually take advantage of our telescopes, so it wasn't like it sat out there fallow, and we had it online. So anyway, so it'll come back. You'll see.
Great.
Good night, everybody.
Night. Paul, you got anything else?
I just want to thank Rich and everyone at your end in the US end for making the time on your Friday evening. It's the timing is not necessarily easy. It's a little bit easier for us on Saturday morning, but it's been really good. I think we've opened up some real possibilities, Rich, with collaboration, technical colleagues, visits. I noticed the Western SARA conferences coming up. What is that, March? I think it is, Rich. Well, you're on mute. You're muted, Rich.
Okay.
Yep.
Yeah. The SARA conference, March 17th to 18th, will be at Owens Valley Radio Observatory in Bishop, California. And you will be able to do that remotely. If you want to do a paper for it, you can do it remotely. We are looking for papers. I'm saying the Eastern Conference appears to be somewhere in the end of July this year, July, August. And that'll potentially be at Green Bank, but it may not be. But that'll also be remoted too. So you guys can contribute from Australia to the conference.
Yeah, I think that's what we've gained out of COVID and so on. We've gained these hybrid conferences. It's opened up a lot of possibilities. It's,
Absolutely.
Really good. We might be able to do for the Western and then again for the Eastern, we might be able to do a sort of a summary of what's happening at this end. We can pull our resource, the Australian resources, and do a presentation and make some contacts with your guys.
Sounds good.
And Andrew's got plenty of time now.
Yeah, you're never more busy than when you retire. Trust me.
I retired and then I went back, so I'm still teaching next year.
Okay. Thanks,
All
Paul.
right,
and
thank you, everybody.
Thanks, guys, and hook up with everybody, and we'll get this YouTube video up in the next few days.
Yep.
All right.
Great stuff.
Thanks a lot.
Thanks, Rich. Thanks, everybody.
Thanks, everybody.
See you.
Good night.
Good night.
Good night.